Good afternoon, class. Welcome to Cool Math Games math class, taught by me, Professor Caleb. Today we will be going over the first derivative test. To get started, we're going to kind of go over what this test teaches us and how to use it and what it covers. So this test helps us identify local maximum and minimum values of a function. Understanding this concept will help us to analyze the behavior of functions and solve optimization problems. To start, let's recall what a derivative tells us. The derivative of a function gives us the slope of the tangent line at any point. If the derivative is positive, the function is increasing. If it is negative, then the function is decreasing. So, now let's go into the explanation of the concept and tell us what it states. So there's three things that it states. If the derivative changes from positive to negative at a critical point, then the function has a local maximum at that point. Number 2, if the derivative changes from negative to positive at a critical point, then the function has a local minimum at that point. Number 3, if there is no sign change, the critical point is neither a max nor a minimum. And a critical point occurs where the derivative is 0 or undefined. To apply the test, we first need to find the derivatives, set it equal to 0, and solve for the critical points. Then we check the sign of the derivative on the intervals around these points. One way to think about this test is to imagine that you're hiking on a trail. If you're going uphill, increasing slope, reach a peak at the top, and then start climbing down again. That peak represents a local maximum. Similarly, if you're going downhill into a valley, then start climbing back up again, that represents a local minimum. A useful trick to remember this test to visualize a number line with a plus and a minus sign. When checking sign changes, imagine the function switching gears. When the function switches from positive to negative, it is like reaching the top of a hill and then descending. This means there's a local maximum. When their function is negative to a positive, it is like reaching the bottom of a valley and then climbing. This means there's a local minimum. And if there's no sign change, then that means it's just a plateau. There's neither a maximum nor a minimum. It is also helpful to use a sign chart to track the behavior of the derivative. Draw a number line and mark the critical points on the number line, then test the values at each of the intervals. This visual approach can help make it easier to see the function's behavior. Now we're going to kind of go over a problem to make sure everybody understands how to use the first derivative test. So we're going to consider a function. We're going to find the derivative of that function on your paper. Then you're going to set that function equal to 0 to find the critical points. Then you're going to factor, find the critical points, and to test the signs of the intervals around these points, pick one of the numbers. It's positive, it is increasing. And if we plug in another number and it is negative, and then it is decreasing. And to interpret the results, the derivative changes from positive to negative, therefore there is a local maximum. The derivative changes from negative to positive at whatever point, then there's a local minimum at that point. So, to conclude this lesson of the first derivative steps, we are able to determine where the function has a local maximum or minimum. This method is essential for analyzing graphs and solving real-world optimization problems. Now I like you to go out and do one on your own and keep practicing, as that is the best way to learn how to use this function correctly. Thanks, class. Everybody have a fantastic day.